Hello, I'm Nicolette Pomba-Van-Zyl, editor of ESI Africa magazine, coming to you from the African Utility Week studio. Today I am sitting with Jack Radmore from GreenCape, who is the green finance business Analyst. Welcome, Jack.
Thank you very much for having me.
We're going to be talking about small-scale embedded generation. I just want to start off with how do you define SSEG?
Right. So SSEG is still a term that largely is not defined. In terms of what the National Energy Regulator says, it's any form of generation that's under 1 megawatt that's located on a site where electricity is also consumed. In terms of the regulations, what we're looking at is that the majority of the energy that's actually being generated by the source is being consumed on site as well. But there becomes a time when energy will also have to be exported back onto the grid. So the generation actually has to be embedded on the customer side of the electricity meter, so it actually can be measured on what's coming back. So the system is literally and physically embedded within the system.
So somebody that wants to invest in SSEG, what are the technical requirements for that person, as well as the technical requirements on the municipality side?
So obviously the connection of any form of generation to the municipal grid has numerous implications, not only for the customer but for the municipality as well. So all of the technical requirements in this space are done to ensure the safety of both the customer installing the system, the general public and the municipal staff, and also to ensure that there's limited effect on the municipal supply. Obviously, the technical requirements for these systems vary quite drastically depending on how the system is designed. For example, the technical requirements for a system that's going to be feeding back onto the municipal grid is going to be quite different for a system that's completely off-grid, so no way connected to the municipal grid. But if we focus mainly on the systems that are feeding back onto the municipal grid, three important technical requirements are firstly a bidirectional smart meter, a meter that has the ability to measure both electricity being consumed by the customer and electricity that's being generated and pushed back onto the grid. Another important element is your anti-islanding device. So this is a device that's installed in the system to ensure that the system's not able to feed back onto the municipal grid when the municipal grid is down. So for example, if the municipality is doing maintenance on their grid and they drop the grid for a time period, if they don't know that your system is able to isolate itself, that grid may remain energized and may be very dangerous for their staff. In the Western Cape, systems still need to reply to all of the grid codes of South Africa as well. And in the majority of municipalities, they also need to be signed off by an electrical engineer, given that in South Africa, our DC grid codes are not yet fully developed. So I think in terms of these systems, those are three of the most important technical requirements that customers and municipalities need to be aware of in the terms of SSEG.
With the uptake of small-scale embedded generation that we have seen in the Western Cape particularly, what is it that on a policy side needs to happen in order for this to grow beyond the Western Cape?
Obviously, policies are very important in this space, and I think three of the biggest barriers that we've seen over the last sort of 5 to 10 years have been a lack of effective tariffs for small-scale embedded generation, a lack of rules and regulations, and a lack of effective bylaws. Once these three elements are in place, they become massive drivers to create a conducive environment for the uptake of SSEG. GreenCape has been focusing very heavily on trying to assist municipalities who are largely under-resourced in developing these regulations to create the correct policies and tariffs to move forward. So what we've done is we've created a basic wireframe for municipalities that includes everything that their customers and other stakeholders need to know in terms of regulations. It includes what bylaws are required, how we recommend they design tariffs. So I think with something like this in place, a municipality can quickly and easily adapt to the changing landscape.
It can be a very complicated process, which this document has now made not simple, but easier for municipalities to accept small-scale embedded generation.
Definitely.
But what examples do you have in the Western Cape that you can talk about?
Yeah, so over the past sort of year and a half, we've seen quite a rapid uptake as the price of renewable energy, specifically PV, starts to decrease. In the city of Cape Town, for example, they've had 185 applications for SSEG systems. They've already approved 135. The city themselves have got installations on their own buildings. We see the electricity department in Bloemhof and Bellville. They have a good system in place. And then we see the guys that have good business cases. So the guys that need to keep things cold during the day. So your wine farms, your pack houses, your fruit growers, those guys are starting to implement this as well. So we see Fred and List, series fruit growers installing systems. So we're seeing a massive uptake, and we assume there's more than 1,000 installations in the city of Cape Town alone. So there are quite a few examples of really good systems going out.
And from various industries as well.
Exactly.
Is the small-scale embedded generation mainly generated from solar PV?
Yeah, so in most cases it is PV at the moment, just because of the flexibility of the technology and the price. So over the last sort of 1 to 2 years, we've seen the price of PV drop by about 40 to 50%. So it went from upwards of about 30 Rand per watt peak, right down to now we see some examples of down to 15 Rand per watt peak. So it's becoming largely affordable technology, not only for our large-scale customers, but for your middle-class residential customers as well.
And as GreenCape is an organization within the Western Cape and having this huge growth of the SSEG in the market, and you've done a lot of work into that research, development, really analyzing that market extensively. Where do you see that market growing beyond the Western Cape and in other regions in Africa?
It's going to be a very valuable market over the next couple of years. As I say, the price of PV is dropping drastically. The real game changer in this space is going to be the price of batteries. We see Tesla coming into this space now. They've now installed about 100 systems in South Africa. They see South Africa and Southern Africa as one of their potential biggest markets. And as the price of batteries decreases, SSEG is going to become a valuable input, not only again for your high-income customers or even your residential customers, but for your low-income customers as well. So I think in that space, in your off-grid rural installations, in your low-income customers, there's going to be a massive growing opportunity in terms of SSEG.
Right, so business as usual for the municipalities is definitely changing.
Definitely.
What do you advise them?
So I think the two most important elements in this space are effective tariff design and a quick, streamlined application process. So in terms of tariffs have become the most influential tool a municipality has to ensure what customers are doing is to the benefit of not only those customers, but to the municipality and the country as a whole. So what we're trying to do with tariffs is we're trying to ensure that these sort of financial incentives are used to ensure that private investment is being used in the supply crisis. So basically we want customers that can afford to install SSEG to be incentivized to actually install it. And in terms of an application process, if we have a 3, 4, 5 month application process that's vastly difficult, customers aren't going to do it. This is going to result in dangerous systems that aren't registered with the municipality. That makes grid management very difficult. So if we have an application process that customers are able to quickly and easily fulfill, it allows the municipality to effectively manage their grid and these new exciting generation sources on it as well.
Jack, thank you very much for sharing GreenCape's research into this amazing sector, which is, could potentially be the next mobile explosion within the African market.
Definitely. Thank you very much for having me.
Thank you for watching. I'm Nicolette Pomba-van Zyl, editor of ESI Africa, coming to you from the African Utility Week studio.